Good afternoon, everybody. My name is GT Hill from a YouTube channel called Death Wears Bunny Slippers. For every time you click a link, I get paid 1,000th of a cent. So if you guys could help me out there, that'd be awesome. So my little talk today is on proper enterprise, proper enterprise Wi-Fi channel sizing. So this is just kind of a guideline. There's some good information in here. For 2.4 gigahertz channel sizing, 20 megahertz. I think we all know that. On the 5 gigahertz side, if you don't have time to listen to this, for those of you who are watching it recorded, too long, didn't listen, didn't site survey, didn't have the damn time, your answer is still going to be 20 megahertz. Yeah, because a lot of us think that it's, well, most of the time, but a lot of us like the idea of having really large channels because it makes numbers really, really cool. But you have to ask yourself, why do you want larger channels? There are some things to think about. Larger channels are not always better. Larger channels equals lower SNR. For every time you double the channel size, you lose 3 dB of transmit power. And remember, anytime you're on a channel transmitting, you have to turn around and listen. So if you listen 20 megahertz wide, and then you start listening 80 megahertz wide, or I could curse and say listen 160 wide, you get more interference, right? If you could hear like a dog, you're gonna hear more stuff, so that's bad also. More clients per access point equals more contention. So the contrary to what having larger channel sizes is to do something different, is more APs, which all the vendors in here are happy I'm saying this. Or resellers and VARs, sorry, and Gregor. You could be creating co-channel interference because, yes, ghost frames are real. That's not a joke. Ben already left. I was trying to give him pay him some compliments here. But you could be creating, being the operative word, be creating more co-channel interference. When your APs are on larger channels, they're occupying more spectrum, which means you have less for other access points. And number 4, you've fallen prey to marketing. Right? I was having a conversation at lunch the other day, and why are larger channels, why do they exist? They exist for the consumer market. And all these advances that we hear about, 99% of them are out there because the consumer market wants to put new labels on their boxes every 9 to 12 months. That's actually real. That's why they have to do that. That's why they're doing what they do. Larger channels look really cool, but in real life in the enterprise, it's not always realistic to do that. So the rule that I started with, is a real rule. If you're not sure, start with 20. If you don't have the resources to do what needs to be done, start with 20. 3 reasons to have larger channels than 20 megahertz in 5 gigahertz. 1, you don't have budget for enough APs. Okay? So if you actually don't have, and this is a real thing as much as it sounds like a joke, this does exist where it's, look, I can't afford a lot of access points. I need as much capacity as I can, then larger channels may be right for you. But if you don't need if you have enough money for extra access points, more APs with smaller channels will always win, except for number 3 listed up here. You always have better experiences. You're one of the very, very, very few people that need 200 megabits per second to a client device. Single client device. So if you need to exceed whatever throughput numbers the vendors are putting out now for 20 megahertz wide channels, if you have a single device that needs to exceed that, larger channels may be right for you. And then number 3, you actually have the data to back up that larger channels are okay in your environment. This is not done as often as you would think. And notice that I said data. So as many of you know, I don't actually work for a YouTube channel, but I do work for a company that is a lot about Wi-Fi data. And we have a lot of it. Hundreds of thousands of access points, millions of client devices worth of data on how Wi-Fi operates, among many, many other things. Does anybody remember from last year? Probably not. The worst protocol in networking that has issues is Wi-Fi. Number 2 is ARP. Whoever said ARP wins. ARP is the second worst protocol on all networks today. Weird. So here's a screenshot, kind of a composed screenshot of some data that we got out of our system. Now this is one of the things we do. The name of the company is Nyansa. Product is called Voyance. One of the things we do is we look at the best performing sites for everything from Wi-Fi all the way up through applications, every layer, and we say, how do they compare? This is best performing Wi-Fi sites. It's a long discussion on how we choose best, compared to the worst performing. So you kind of take top percentile, bottom percentile, and you check that out. And you'll notice that the top performing sites are using smaller channels. It's not definitive. That means you shouldn't do that, or you should only do 20 megahertz wide channels. But it is data to back up that by the way, this is representing a couple 100,000 APs, I think 3 million clients. So it's not our entire data set, but it's a big part of it, showing that 40 megahertz channels may not be right for you. Another piece of data that, and again, this is a little bit of a vendor pitch, but another thing that we're also showing here is that anytime you make a change to a network, one of the problems is how do you know if when you make a change that you see improvement? Can I have people talk to me? Okay. How do you know if your network improved? The help desk doesn't call as much. You test it, right? Testing is okay. Testing is really, really difficult to test real world experience. So one of the things our system is sitting there doing all the time is saying, what's the current crap experience that people are having, and what percentage of people are having crappy experiences? So these numbers that you see up here, I'm gonna zoom in a little bit. Oops, that isn't actually what I wanted to do. Is what you see is, you see this graph, how this graph goes down. Down is good. This is clients that had poor Wi-Fi performance. You want that number to go down to ideally 0. That's not realistic. The best networks we see out there have about 5% of the users have issues, but that's a pretty rock solid network. But what I'm trying to show here is that there was a configuration change. So Voyance tracks configuration changes, and once that config was changed, there was an 11% decrease in people that were having problems with Wi-Fi, and that was changing from larger channels to smaller. Again, this data is not definitive. This is not saying, go do that, that's mandatory. But when I look on things like the EDUCAUSE forums, and there's these long discussions on what channel sizing to use, many people default to larger is better. I want to push that limit. My recommendation is, if I were to deploy a network today, and I don't really have a handle on all this, and I have it site surveyed, or I inherit a network, and I'm worried about performance, immediately I'm dropping everything to 20s. Right? If I have poor performance and I just need to make a quick fix, and I've done this at customers of ours, I'm like, hey man, just try going from 40s to 20s. Let's just see what happens. And I've seen numbers much bigger than this. I think that is all I have. I appreciate that very much. Love you guys. We'll see you next year.